Hello and welcome everyone. In this day 37 learning, we are going to be looking at hashing basics and a simple hash function. In the last session, we have looked at symbol tables, which where we were also referring it to be as an hash tables in Java, if maybe. So maps in JavaScript or dictionaries in Python. So there also hashing is going to be used. We used array of arrays where an array contains key and value, and here in this hashing basics we are going to be looking at how we can build an hashing function which is going to help us in faster retrieval and also having to manage data storage better, right? So what is hashing? So hashing is a technique to optimal store and retrieve data, store and find data. Let's take an example and understand hashing better. So let's say we have an array 12, 45, and 78, 91, and 23. So let's say we want to find 91. We might need to search either if it's a sorted array, then we have binary search option which helps us find items better. Else we might need to linearly search items. What hashing helps us is, let's say we have a value 91. We can hash this and we can say 91. I'm just taking this as an hashing function. This will give out 1, and we can store that in an index of 1. So let's consider this as an index of 1. Similarly, this value 12 mod 10 will give us 2 index, and this will be a fifth index, eighth index, and 3 index. So that way, let's say once we want to look up for a value, reaching this specific index will give us quickly the value that we are looking for, right? So so let's say the same array can be written as index 0, 1, 2, 3, 4, 6, 7, 8, 9, and here at 1 we can place 91 value, and 12, 45, 78, 12, 45, 78, 91, 23. So other values, let's say we keep it empty also, that's fine, right? So this might be a possible uh, hash table implementation. Let's say we want to find a value of 91. Quickly looking at index 1 will give us in a space complexity of 1. So that's the whole idea. So an hash function can be as simple as uh, key and table size. Say return key mod by table size. So in this case, we were considering a table size of 10. So yeah, this can be a simple hash function, right? So all good, all looks good till here. Uh, so we can expect from a good hashing function a faster retrieval, fast retrieval and storage. store data. And similarly, spreads evenly, uh, avoids too many collisions, and returns the same index value. So this point we are fine, spreads evenly we are fine. These are 2 points that we might need to think a little bit more on. So let's take another example where we have an array of characters, say for example CAT and BAT and apple, something like this. So let's say we consider all of these values have, let's say we should also understand ASCII value of A to Z starting from 97 to 65, 97 to 122, and similarly capital A to capital Z starts from 65 to 90. There are about 26 characters, as we know, right? So let's say we consider this value. This would be 99 plus 97 plus 116, which would be around 312. Similarly, for this one, it would be around 311. And this one I will not calculate here, at least. Let me just leave it as it is. So these two can be hashed out like 312 and 311, and this would be around 97. Piece will be 112, and L would be 108 plus 101, right? So 97 112 will be 224 108 plus 101, right? So 15 plus 5 0 to carry over 3 1 530. Let's say these are the values, right? So this can be hashed out to, let's say, 312 mod of 10, 311 mod of 10, and this one 530 mod of 10. This gives out 2 comma 1 comma 0, right? So let this be the hash function, right? So now let's say we get another string added here. Instead of cat, we also get ABC, right? A at a value of ABC, which contains a value of 97, 98, and 99, right? So 3 5 1 6 394, and this, when hashed out to, gives out a value of 4. Similarly, when we get a value of CBA, this also leads to a hash value of same 99, 98, and 97, which comes out to 394. When hashed out to 10, it gives 4. So let's say if these two strings are there in this array, then we get an index of 4 for both of them, which is like a collision. So one index taking up two values is difficult to handle, or there is a overlapping between these two values at index 4, right? So that's that's a simple understanding on how a collision might occur, right? So there might be collisions in a numerical value or number type inputs as well, but just I have taken this example of strings here, right? Okay, so let me switch to JSBin editor and let's go through some code snippets. Okay, so here I have certain uh, comments defining why hashing and why what is hashing and what are the key features of a good hashing function. So also a simple division hashing function for a numerical value and a string hashing function. And here I have, okay, so division hashing function of 1 2 3, string hashing of these gives this. And yeah, see the size or the uh, with which this is getting divided with. And similarly here, while string hash for this one gives out this one, and collision at, so next one is a new function that I have not discussed, but here I have a simple hash map with collisions, set of entries which are something like this, right? So for each entries we have key value and index is type of number, we use this, and we use string hash function, and we put it into a bucket at specific indexes, right? So if it has a length of 1 or greater, then we say collision at a specific index, and we push it into a bucket and insert it at a bucket. So that's one thing. Yeah, like for example, let's say here we have so here we have inserted cat at 2 and also tag at 2, right? So final hash table, if you see, these two values are at index 2 because string hash gives out a collision for these two, and bucket 3 has one object, and all these are in different objects, right? So that's the whole idea. It should be a simple function. I will stop this video for now. uh, this was a basic introduction of what hashing looks like and uh, when a collision occurs. Hope you found this video helpful. Please do like and subscribe to my channel. If there are any doubts or comments, please do post them. I would be happy to look into comments and respond there as well. Thank you.